Welcome to the Explainer. Today, we're going to talk about something pretty incredible, how a technology that was once just for prototypes is now completely changing how millions of people walk, one custom-fit layer at a time. So let's start with a number, 17 million. That's how many people in the United States alone have trouble walking. It's a huge number, and it represents a daily challenge with something so many of us just take for granted. And it's a problem that engineers are tackling head-on. So, here's how we're going to break it all down. First, we'll look at the basic science of a single step. Then we'll get into the device that's at the heart of the solution, the AFO. We're going to look at what they're made of, how they're made, and what it all means for the future. So let's start with the absolute basics of walking. All right, first up, why does walking, something that seems so simple, sometimes fail? Well, it all comes down to the biomechanics of what's called the gait cycle. It's this really complex, coordinated sequence of movements that makes up every single step we take. You see, every step is a precise mechanical process. It's split into two main phases. There's the stance phase, that's when your foot is on the ground, and that takes up about 60% of the cycle. The other 40% is the swing phase, which is when your foot is moving forward through the air. In that stance phase, it's not just one single motion. It's actually this carefully choreographed sequence of 5 distinct events, all the way from your heel first hitting the ground to your toe finally pushing off. A smooth, stable gait really depends on every single one of these moments happening just right. But what happens when that system gets disrupted? From things like nerve injuries, muscle weakness, or a stroke. Well, you can get a condition known as foot drop. It's basically the inability to lift the front of your foot. That means the toes can drag during the swing phase, which, as you can imagine, creates a huge risk of tripping and falling. So, how do we fix a problem like foot drop? The main solution is actually a pretty remarkable piece of assistive technology. It's called an ankle-foot orthosis, or AFO for short. And you can think of it as this L-shaped brace that's specifically engineered to support the foot and ankle, keep everything in the right alignment, and just generally help with a more natural walking motion. But here's the thing, AFOs are not a one-size-fits-all kind of deal. They come in all sorts of designs for very specific needs. You've got the solid AFO, which gives you maximum stability by basically locking the ankle. Then there's a hinged AFO that allows some controlled motion. And for foot drop, you often see a posterior leaf spring AFO, which is more flexible and gives a sort of spring-like lift. Now, how well an AFO works depends hugely on what it's made of. And trust me, the materials used for these devices have evolved dramatically, completely transforming how they function and how comfortable they are. For centuries, AFOs were these clunky contraptions made of heavy metal and leather. Yeah, they were strong, but they were also bulky and had to be permanently attached to just one pair of shoes. Today's AFOs are a whole different world. They use advanced plastics and composites to be way lighter, less obvious, and you can wear them with almost any shoe. Choosing the right material is all about trade-offs. Polymers, for example, are super lightweight and easy to mold, but they can warp. Metals give you incredible strength, but they're heavy. And then you have the superstar, carbon fiber composites. They give you the absolute best strength-to-weight ratio, but that amazing performance comes with a much higher price tag. So what this really boils down to is that having this whole menu of materials to choose from means that clinicians and engineers can create devices that aren't just functional, but are also lighter, more comfortable, and can just seamlessly fit into a person's everyday life. But look, a great material is only half the story. The manufacturing process is what actually turns that material into a perfect, personalized device that truly fits the person wearing it. The traditional method is a real craft, but man, it is labor-intensive. It starts with making a plaster cast of the patient's leg. Then that mold is used to create a model, which a technician has to shave and sand and build up completely by hand. Then they vacuum form a sheet of hot plastic over it. It works, but it's messy, it takes a long time, and it really depends on the skill of the technician. Now, compare that to modern additive manufacturing, what we usually call 3D printing. It completely transforms this into a clean, digital process. A 3D scanner grabs the leg's exact shape in seconds. That data goes into software where you can modify the model with incredible precision, and then you just send the file to a 3D printer, and it prints the final AFO directly, layer by layer. And for patients, this new technology is an absolute game changer. I mean, we're talking about getting your device in days instead of weeks. It lets you create these complex, hollowed-out structures that make the AFO way lighter without losing strength. And because it's all digital, you can get a perfectly customized fit with unbelievable precision, all while wasting way less material. So, what does this whole shift from plaster and steel to digital scans and carbon fiber, what does it really mean for the future of assistive medicine? Well, we've moved from an era of just kind of brute force support to one of elegant, data-driven solutions. AFOs aren't just static braces anymore. They're becoming these high-performance tools precisely engineered for the unique biomechanics of an individual's body. This revolution in personalized manufacturing really leaves us with a fascinating thought. The ability to scan, design, and print custom medical devices on demand just opens up a whole world of possibilities, not just for walking, but for every aspect of our health and performance. So, what's next? Well, that's only limited by our imagination.